Okay, simple payback analysis. This is when the bean counters say, what's your bottom line? How much is this going to cost me? Well, what are you talking about now? Or are you talking about the entire? Oh, don't talk to me about, I want to know how much I have to write the check for. First cost pricing, right? Then they say, well, what's the payback on that? What do you mean? Well, how many years before I get my money back? And you would do a simple payback analysis. Okay, price of energy is this, total cost is this is the number of years. Well, there's some problems with that now. Number one, who knows what the price of energy is going to be a year from now? 5 years ago, if I told you that we would say, good God, am I glad the price of gas dropped below $4 a gallon. You guys would have got out the butterfly nets and been calling 911. But isn't that the case? Aren't we happy when the price of gas drops down to less than $4 a gallon? I have a friend in the UK that says when it hits $20 a gallon, come and talk to me. I'll be sympathetic. Anyway, so we have no idea what the price of fuel is going to be. So simple payback analysis is mathematically very difficult. Let's go beyond that. Let's talk about life cycle analysis. Boy, is that a can of worms. When you're talking about life cycle analysis, how far back do you go to figure out life cycle? What is a life cycle cost? What is the cost of the material? What is the cost of the product in an environmental sense or an ethics sense? Remember the triple bottom line from yesterday? What does it cost us to get the product up to that point? Well, you know what? My rule of thumb is that I only look at what I can influence. So, if a guy buys a circulator pump, I'm going back to the hydronics because that's what I know. A guy buys a circulator pump from me and he wants to know what's the life cycle cost of this thing, if he's smart enough to ask that. Otherwise, I got to beat him on the head and tell him what the life cycle cost is. It's the cost of the pump, it's the cost to install the pump, it's the cost of the energy for the pump during the expected life of that pump, plus the service of that pump and the disposal of the pump when I'm done with it. Is that a reasonable description of life cycle? Yes, it is, but you will be amazed at the variance that I see in life cycle costing. There's life cycle costing and life cycle analysis, okay? And some of the people absolutely freak out if the disposal costs are not involved in there, okay? Like compact fluorescent lights, they found have a small quantity of mercury in them now, and they insist that that be part of the life cycle analysis. My personal opinion is there's a small amount of mercury and there's disposal avenues available. For example, for anybody that cares, Home Depot, for example, will take them if you take to the customer service. And there's all kinds of ways, okay? For you guys that deal with anything that has combustion, you know as well as I do that it's absolutely critical to tune it up, okay? You buy a car, back in the day, we bought our first cars, and it was probably a beater. But we could open up the hood and climb in with the engine, and what's the first thing we did when we bought that car? We went out and we bought plugs, points, condenser, air filter, gas filter, timing light, a real cheap timing light, but we had one. What else did we get? But you understand the point. And why did we do that? 2 reasons. One, we were going to get the most we could out of that $5 fill-up. Second, it was going to purr. Man, it was going to sound solid. Now let me ask you a question. If we're willing to do that with our first car, back when we could, what's the difference between that and a mechanical system of a home? A furnace or a boiler? Okay, try to sell that to a building owner, that we're here to tune up your mechanical system. Well, why? It isn't broke, so why should I fix it? I did a class where I had 60 contractors sitting out there, and I said, and I had a combustion analyzer in my hand. And I said, how many of you have one of these? 3 guys in the same uniform sitting next to each other, all raise their hands very proudly, and they're looking around, and there's nobody else in the room raising their hand. And they're going, yeah. And I said, okay, you guys share one, right? Yeah. Okay. They had one, right? And they shared it. Okay, I'll buy that. At least they had one. This is in hydronics territory, and I was at a distributor that sold a lot of hydronics, and I said, okay, how many of you guys have installed Munchkin boilers? 2/3 of the hands go up in the air. Talk about setting the hook. Next PowerPoint slide was the installation manual for Munchkin boilers, page 12. When you install these things, you must do a combustion analysis. In other words, once you get it set up, tune it up. So if you're supposed to tune it up when you first get it, and you're supposed to keep it tuned up like you would a car, why aren't we doing combustion analysis? How many of you are familiar with the 2030 plan, where everybody's going to go carbonless by 2030, and it's new construction, demolition, and major renovation? Okay? AIA signed off on it, ASHRAE has signed off on it, and USGBC has signed off on it, and the Council of Mayors have signed off on it. So everybody's all for this thing. I went up to the fellow that wrote it, he's an architect out in New Mexico, and I said, this is all well and good, but you know what? You're talking about 20 plus years down the road. Our guys can start fixing the problem tomorrow. Well, how's that possible? I said, we train, we equip, and we motivate contractors to go out and do service on individual units, and we teach them how to do combustion analysis. We teach them how to make the best of what we got out there. We teach them how to sell the concept to the building owners, and they're going to start making improvements starting tomorrow. And it was like the LED turned on over his head. And this is what we're all about. We're talking about, let's do combustion analysis. Let's start tuning stuff up tomorrow. You got to be careful when you hear numbers that talk about efficiency, because efficiency depends upon what you're measuring, how you're measuring it, what the circumstances are, and what the formula is. I was at ISH in Germany, and I went back where they have all the Asian companies. And there was a Korean company there, and they had a flyer. Their furnace was 105% efficient. And I asked the fellow, does it create energy? And he goes, no. I said, but how can it be 105% efficient? He goes, that's what the efficiency test said. Now, I'm going through every, being an engineer, I go through every efficiency test that I can think of, and cannot imagine how you would get 105% under any circumstances short of creating energy, which we know is unlikely. I said, what test did you use? Oh, our test. Oh, so you wrote your own scoring test for your own furnace? Yes. So be careful when you talk about efficiency. Look under the hood and see how they came up with that number, what the parameters were, and train your people to do the same thing.